Thank you so much. I'm honored for the opportunity to address you. I'm saying this because I'm trying to fill in time as I turn the technology on. And here we're alive, I hope. Yes, great. And I've been incredibly honored to serve on the AXA Research Fund board. For a lawyer, I have to confess that I felt outgunned many times in the conversations with the scientists and those who are actually connected to the real world as opposed to the policy world that I live in, but it has been enormously informative and inspirational to see what true leadership by corporations can provide for the public good. And I came to this skeptical, and I live it and practice it without that skepticism anymore. Now, I've been in this field thinking about technology now for more than 20 years and the way it affects policy. And we recognize, of course, that we're in the middle of a revolution, a technical revolution for some time now. But maybe as a measure of my feeling old, I'd like to step back a bit and think about what we can learn from the mistakes we've made and look ahead to the problems that are likely, given the emergence of data, big data, as a central organizing idea in the context of science. And the particular mistake I'd like to begin with, the mistake that we made without even recognizing we were making it, I think, is related to nanotechnology. And nanotechnology as it connects to the field of legal patents. Now, whenever I say anything about intellectual property, immediately people think I'm going to say something against intellectual property, or I'm going to say that intellectual property is bad. And I want to say that I am not against patents. I'm not even against patents in the context of nanotechnology. But what I want to do is to note a difference that other academics, first Mark Lemley and then Professor Reynolds, have noted about how the way we apply patents in this field could matter. A difference that is unnoticed, I think, by policymakers, but we can see quite clearly if we distinguish the 20th century from the 21st. And if we think about foundational technologies in each of these centuries, how do they relate to the practice of protection? So in the 20th century, the foundational technologies of computers and software and internet and biotechnology, each were born patent-free. Computers, because originally from the military and then from AT&T and IBM's consent decree, were built and developed without patents protecting the core technology that underlay them. Software was, until the 1980s, not even patentable. The internet itself, because developed by the government, TCP/IP was free, and because of Tim, as in Tim Berners-Lee, the World Wide Web was originally built as free. And even biotechnology, of course, DNA as a product of nature was not patentable. The methods that were developed to access and manipulate would have been, but they weren't, because originally, at least, norms and law forbid the great researchers from encumbering these innovations with patents. So the 20th century, all four of these core foundational technologies, the foundation to an extraordinary technical innovation, were patents free, and patents were then built on top of these core free technologies. But in the 21st century, this basic frame has been radically different. We basically have patents all the way down. So in the context of nanotechnology, there has been what has been referred to as the gold rush for patents, building basic building blocks in nanotechnology, covering thousands of patents, even the single carbon nanotube itself having hundreds of patents reading on the very same technology. This patent thicket refers to a problem that Michael Heller has called the problem of the anti-commons, where instead of a resource that everyone can draw on, it's a resource that incredibly no one can draw on because of the number of people who can say no. And he describes the tragedy of the nanotechnology anti-commons, as Professor Reynolds put it, An analysis of the nanotechnology patent landscape suggests that nanotechnology gold rush has created an anti-commons in nanomaterials. Patents in nanomaterials are broad, overlapping, and fragmented. Unless action is taken to eliminate the nanotechnology anti-commons, however, transaction and strategic costs may stifle nanotechnology's incredible potential. Now, Professor Reynolds and Mark Lemley's position about the anti-commons in nanotechnology has, of course, skeptics who are not convinced that patents have presented a problem. There are plenty of patentophiles out there. But my point here is different. My point is to think about this difference between the 20th and 21st century and ask this question: did we decide at some point, affirmatively decide at some point to adopt this radical change for how we deal with foundational technologies? Was that chosen? Did anybody even understand what this new premise would do for the opportunity for innovators to build on this fundamental technology? Did somebody say, geez, the 20th century didn't have enough technical innovation, so we've got to change the rules. We have to get more innovation than that sluggish 20th century provided? And obviously, the answer to that question is no. This was the unintended consequence of basically lawyers mucking around with the way innovators do their work, and it's a consequence that no policymaker took time to reflect on before it actually embedded itself in the ecology of nanotechnology. Now, my point is that a better way, when we think about these radical changes of technology, is to step back and to look and ask, does this difference in technology make sense of the existing systems for regulation, and to choose whether to adopt the existing systems or to modify them. And I want to think about that question in particular in the context of data. We've heard a lot in the past couple of years about the extraordinary value of open data projects. Projects where the data is made available to many researchers to use and build upon for their own critical work. Enormous progress to recognizing the value in free data, the value to corporations around the world from the opportunity to take data and turn it into resource and valuable products. And the open access to science movement has begun to teach people about the incredible importance of guaranteeing access to scientific knowledge to people around the world, not just in the rich, information-rich countries like in the West or in the United States. The Public Library of Science has built an extraordinary number of incredibly successful journals that have committed the work of those journals to the public domain through licenses that guarantee permanent access for everyone, everywhere. And the number of journals that are adopting open access principles is going through the roof. And increasingly, people are seeing the value in open data. Here's even a McKinsey report describing how open data unlocks innovation and performance with liquid information, showing how this opportunity complements the commercial process to produce value both for commercial and for research. But this different data that I want to think about today, we can think of as a new kind of data in the field of open data. And I want to think about that new kind of data in the context of health. Because what we're seeing right now, just in the beginning, and over the next 20 years we will see explode, is the amount of technologies devoted to gathering from consumers health data that will automatically be collected and sent to repositories to be studied and used. And not just automatically collected, but self-consciously collected. 23andMe, a private DNA decoding company, has now cornered a huge market in private data about DNA, doing extraordinary research, just raised $150 million, which is 70% of the United States government total budget for personalized medicine. Now, these data will support millions of ways that consumers will collect the data and to make the data usable, to give researchers the opportunity to study how consumers in the field are reacting and experiencing this extraordinary exposure to information. And this sea change in data will affect how research is done. We go from a world of small samples, where scientists depend on tens of observations once or twice a year, to enormous samples, where scientists will have the opportunity to look at tens of thousands of observations every single day. And what this means is these enormous samples will mean data companies will increasingly be in the middle of the project of scientific research around health. Technologists will come to health, as they increasingly are. Data companies will be asked to analyze data in what now unimaginable ways because of their unique connection to consumers and the information consumers voluntarily provide. Google reports that 1 out of every 5 searches is a health-related search, which means there are 2,000 searches per second that Google gets related to health, which they use to inform how consumers are thinking and using health data. Now, these data are encouraging these commercial entities to engage in partnerships with traditional researchers. Google and the Mayo Clinic have worked together to curate health-related facts for people accessing it on the internet. IBM, using its Watson Health Cloud, is working with MD Anderson Cancer Center to treat oncology patients. And Apple, through an open-source research kit, has now connected 200,000 participants in just 9 months to collecting data from their Apple Watches to give to researchers to understand how the consumers are experiencing these data. Now, this is an extraordinary potential for science. And more importantly, an extraordinary potential to help those whose data is collected. Because the obvious consequence of this could be radical change in how we understand medicine and treatment. But I want to suggest that, as with nanotechnology, right now we are seeing an unthinking embrace of the existing norm for data that dominates in the law right now. The norm governing ownership of data, which is presumptively owned not by the creators, the people producing the data, but by the collectors of the data. And all of these data then get collected and enter data silos owned by these different technology companies to build ever more efficient platforms for data for each of these companies. Now, it's important to recognize this is a weird counter-trend to how we think about data in lots of contexts of science and commercial life. It's a weird counter-trend to the way medical data is now being shared. The projects to spread clinical data sharing in the United States with the National Academy of Medicine, the National Institutes of Health, Department of Health and Human Services, all require data sharing of clinical studies, as does the Wellcome Trust and the European Medicines Agency of the EU. And the same with the open access to scientific data, which increasingly is becoming the norm of researchers as they make and produce more data accessible across the web. But what follows naturally from this practice of owning the data you collect, this practice of the pre-big data age, is that the rule is if you collect it, then it's yours. And my suggestion is that, as with nanotechnology, what we should be asking is, does this practice make sense? Does big data plus these monopoly business models produce, in fact, poor data for all of us? Now, there's obvious solutions to this problem. The solutions are to make these data presumptively shareable. If we collect them, then you make it available, anonymized, eventually, cleanly, and completely secured, so that many can invent and innovate with the data collected from millions. That's, for example, the practice that's being followed by Sage Bionetworks. Right now, Sage is running 7 trials with more than 100,000 participants. And each of these participants is giving the power to control what's done with their data. They have access to the data, they have information how it's being used, and they have the freedom to share it with other researchers if they so choose. 75% of the 100,000 participants opted into a regime where their data is shared with others who pass certain standards for qualification to share data. And these other researchers then everywhere have the ability to discover and to invent on top of these collected data. Now, this alternative is clear, an alternative to the winner-take-all economies we see the internet producing with fewer and fewer competitors, where all research would be conditioned on access through these few, where research on this data depends on getting permission from these few to get access to the internet. And my suggestion to the data, and my suggestion is that if the internet has taught us anything, it has taught us that many innovators are better than few. And the ability to block, to discriminates against the new. Because think of the very architecture of the internet. The internet's architecture was what they call simple, or some said stupid. Stupid because it couldn't discriminate against who wanted to use the internet for what purpose. And the consequence of that design, as my colleague Barbara von Schewick put it, is an architecture that enabled a certain kind of innovation. Think about the great innovations in the history of the internet. A browser built by a kid at the University of Illinois, Champaign-Urbana. Hotmail, the first browser internet client developed by an Indian immigrant. ICQ, the first peer-to-peer messaging service developed by an Israeli. Google, Napster, YouTube, all developed by people under the age of 30. Kazaa and Skype, developed by a Dane and Swede. Facebook, developed by Harvard dropouts. Reddit, developed by Stanford dropouts. Twitter, developed by a guy under 30. What unites all of these innovations? They are all produced by kids, dropouts, and non-Americans. They are all produced by outsiders to the dominant corporations that controlled access to the technology at the time, because the right to innovate was held in common. And the architectures to assure competition built into the architecture of the internet produced a better environment for creativity than architectures of control, or at least, maybe, right? Because I'm not here to offer an answer about how we should think about access to consumer-collected big data. What I'm saying is we have to ask these questions about what the rules should be, and to ask these questions now before the future gets codified in the business models of these corporations, because the alternatives then will be unimaginable. Our job is to make unimaginable these alternatives, to ask the questions that no one's interest is to ask. No one, except perhaps everyone, no one except perhaps the public. Thank you very much.